This slide shows how inference is implemented. For SFT Plus and RHF, the code calls load pre-trained model from LLaVA codebase. The SFT Plus model is loaded with the SLT path. Model name LLaVA version 1.57b. Low 8 bits equals true, and device map equals auto. For RHF, the LoRa adapter is added using path model from pretrained. The prompt is then built as user, image token, question, and assistant. The model generates with dual sample set to false, temperature 0.2, and selected max new tokens. For one region, the code uses autoconfig, automodel for casual RM, and auto processors. The message contains an image path and a text question. Then imply check templates build the current VL prompts. Process vision info prepares the visual input, and the model produces the answer. The APIs are different, but the images, questions, and scoring logic stay consistent. For the OOD benchmark, generate images.py creates just text images and write them into my work text images. The script uses size 512 by 512, noise seed 42, noise standard deviation 50, noise exclusion 20, and the stable RGB value 70, 130, 180. It outputs pure noise.jpg, solid color.jpg, geometric circle.jpg, and text noisy.jpg. Each image has a purpose. Pure noise text whether the model admits there is no real semantic content. Solid color text basic color recognition and whether the blue is over associated with sky. The geometric circle text whether a simple shape is interpreted as an animal. The noisy image adds uniform noise to a real image so we can text perturbation stability. The fixed makes the code reproducible. Each notebook saves a standard JSON file. The JSON contains Gamma version 1.0, benchmark name, model information, probes, proposed results, answers, correctness labels, verdicts, and summary statistics. For example, a pro record includes the pro ID, image name, question, ground truth, model answer, whether the answer is correct, and a verdict. For structured probes, scoring usually tolerates substring matching. It checks yes or no. Numbers, left or right, front or behind, and similar short answer patterns. For open descriptions, hallucination is flagged when abstract or non-scene inputs are described with natural objects such as tree, person, or sky. OOD-A2 is qualitative and is not included in the 6-scored OOD probes. Finally, compare probe results.py and compare extreme result.py. Most result by pro ID and output fields such as batch models and all correct. For natural scenes, we evaluate 16 real or structured image probes. The update result is SFT plus 9 out of 16, RHF 10 out of 16, and one region 16 out of 16. The representative failures show different patterns. For contact traps in T1 and C2, SFT Plus and RHF treat decks or kitchen pirates as visual evidence and answer keyboard or banana, even though the ground truth is no. For counting, RHF tend to overcount in T2, E3, and K2. For example, one teacher bug becomes 2, or 5 people becomes 6. However, RLHF does improve on some fine-grained probes. It answers K3 correctly for the dress color, and it improved on spatial relation probes O1 and O2. For the open-ended abstract image A2, SFT plus and RHF describe flower or sky, while one vision stays more literal and says abstract colors with no subject. So one vision is strongest overall, while HF is localized improvement but also regression. For extreme OOD, there are 7 probes. A2 is qualitative, so score accuracy is based on 6 probes. RHF gets 4 out of 6, and one vision gets 5 out of 6. The key examples are B2, A2, and the noisy real image. For B2, the solid blue image asks whether there is a sky. RHF says no sky, which is conservative and correct. One vision says it looks like sky, which shows the semantic projection. For A2, pure noise, RHF narrativized the image as an object pattern and or modern art, while one vision is more literal and says static or noise with no clear object. For the noisy real image, one vision keeps the answer stable, while RHF error persists. So RLHF can be conservative under forced choice prompts, but hallucinates in open-ended noise descriptions. One vision is stronger overall, but still over-associates sparse visual evidence. This slide summarizes the main conclusion. RLHF alignment and one vision style, scaling or architecture improve different failures modes. For counting, RLHF overcounts, while one vision is correct. For contact traps, RLHF remains pyrrhia-driven, while one vision is more grounded. For open-ended invention, RLHF hallucinates, while one vision is more literal. For noise honesty, RLHF narrates noise as abstract art, while one vision identifies static or noise. For perturbation stability, RLHF has persistent errors, while one vision is stable. For semantic projections, RLHF is conservative, while one vision can over-associate. Therefore, RLHF is not valuable because it wins overall. It is valuable because it preserves a behavioral property that scaling alone may not preserve. Future multimodal systems may benefit from hybrid strategies, stronger perception plus failure mode specific alignment. Our experiment shows that multimodal hallucination should be decomposed by failure mode. One vision is stronger on grounded natural scenes, while RLHF retains useful conservatism under sparse evidence.